there you go. Our restaurant management system powered by AI is ready with Smol Agent framework. That it's using the Qwen 2.5 coder model. The kitchen status is operational, all device functioning, no issue reported, staff allocation manager. We are expecting 25% more order tomorrow. Is our inventory sufficient? Hi everyone. I think 2025 is going to be a massive year for AI agents and AI agent related frameworks. And to start with this year, we have already got Smol Agents from HuggingFace. I'm sure you have heard of Smol Agents already from different YouTube videos or some news. If not, then please stay tuned because in this video, we are going to deep dive into Smol Agents and do a bit of crash course and do a bit of crash to help you know everything that you need to know about Smol Agents and in which use case you should use the Smol Agents. So without much further ado, let's go deep dive into my screen and let's share everything about Smol Agents. Shall we? Hey, welcome to my screen and welcome to this crash course about Smol Agents. Now, as I said, you probably already have known about Smol Agents. If not, let me just give you a quick introduction about Smol Agents. So, Smol Agents is a new agentic framework that is being released by HuggingFace. And as the name suggests, it is really small. That means you can literally write agents in just 3 or 4 lines of code, and I'm just gonna show you as well as part of this video how you can actually write Smol Agents for different use cases. Now, just to quickly glance it through their GitHub repository, you can actually check out the Smol Agents repository from this link. You can also just go into Google and search it and get to this GitHub page. They also have created a very basic documentations with like what 4 or 5 links here, as you can see. Now, I have gone through the documentation and I really feel that this documentation is not complete. And I think somewhere they also mentioned it that they are currently upgrading this documentations. And I'm really looking forward to have this Smol Agents framework to be getting matured enough with the time as we go into 2025. Why I'm so excited about Smol Agent is because it has currently solved one of the particular problem that we face with the general agentic framework or general agents. We'll get into that in quickly, but let me first tell you what we are going to cover in this course. So in this crash course, we're just going to give you some high-level overview about what Smol Agent is. I'm not going to take much time because probably you have already seen stuff about Smol Agents already in other YouTube videos. So what I'm instead going to do is going to actually take you through the codes. So I have created like 6 codes, as you can see, and step-by-step codes basically where I have introduced from very basics to creating a multi-agent small agent system. And then as usual in the channel, what we do is we apply any kind of agentic framework or agents into a proper business use case. So that is where we created intelligent restaurant system with Smol Agents that will give you I think a proper business use case where you can use this kind of Smol Agents. So please stay tuned till the end of this video because this is going to be so much valuable that you are going to be thank me later, I'm sure. Okay, so let's go ahead with a very quick introduction about Smol Agents and let's crack on, shall we? Okay, first thing first, as I said, Smol Agents is really an agentic framework or library produced by HuggingFace. If you do not know about HuggingFace, HuggingFace is one of the, I would say, website or one of the company that kind of facilitates all the open source models. I think they have approximately 500,000 plus models in their repository, and this is all absolutely free that you can use from the Hugging Face website. So all of the model that usually comes into the open source community, that usually comes via the Hugging Face space. If you need more information about Hugging Face, please go ahead and check in YouTube. There are thousands and thousands of videos about Hugging Face, how to use their models, how to use their space and everything. I'm not gonna go into that in this video, but I'm gonna refer a few of their features like Hugging Face Hub, Hugging Face Space, as we go along with the code, and I'm going to explain that like as a very brief so that you understand what those terms is all about. Okay, now to install Smol Agents, all you need to do is just install pip install Smol Agents, which means it's a Python based framework. That means you need Python to be installed in your system, so please make sure you install Python if you do not have it already. Okay, now writing a small agent is as simple as these 3 lines, as you can see, right? So this is like very simple. As I said, it's a very simple framework. Now, how does it differ from a normal agentic framework is that in a normal agentic framework, all you do is you infuse some tools like in a JSON formatted instructions, and then the LLM basically produce the JSON output, and based on that, your agentic framework would call the API or call the external tools, get the output, and send it back to the LLM for the final output generation. Where small agents differ is it actually has the capability to think and do some code execution. So that is where you see the code agent as a kind of agent system that they have implemented as part of small agents. And the code agent has the capability to actually write code as it needs, to kind of comply with the instruction that user have provided. So that is where small agents is really, really powerful, and it differs from many other frameworks. And I think previously we had similar framework created, I think by Microsoft, which I think I covered into the channel before, approximately 8 to 9 months back, about AutoGen or I think Open Interpreter or something. This is very similar to that, but this is much, much simpler, because if you have had work with AutoGen or Open Interpreter agents, those frameworks are a bit complicated for, I think, newbies or newcomers to start along. But Small Agents is really, really simple. And I'm going to show you when I'm going to deep dive into the code. Okay, cool. One of the really good thing about small agents is because this agentic framework is really new. That means they have gone through all the other previous frameworks, from Crew AI framework to AutoGen and Open Interpreter and everything. And they have seen what were the issue of all those frameworks, and they have been able to come up with this framework, which I think is really the best part of this particular framework. Now, as they said as well, that they have only written the agents.py, which is their core agentic code, is only 1,000 lines of code. And that is where they have already implemented code agent, they implemented tool calling agent and everything else. So that means it is really, really lightweight. That means it will run much faster. Although I wouldn't recommend to use the small agents for deterministic use cases. And what I mean by deterministic use case is basically, for example, you want to create an agent to do a lead qualification, or if you want to create an agent where you want to do a booking appointment or scheduling. Now, those are all deterministic workflow. That means a user would call to the agent, and agent would basically just do a tool calling and book an appointment or something. So that basically follows a strict uh, a strict workflow. There is no way for agents to do something else, do some intelligent operation as part of the processing. It is more sort of dumb agents that we are creating, where it's just kind of listen to user instruction, and you already set some workflow, and it only needs to follow the workflow to book an appointment, right? So that means the output that you expect from this kind of agents are deterministic. The output that you expect from standard AI agents are always something that you already expect to happen 100% of the time as similar. Whereas the small agents is more useful for more complex tasks. For example, a task where there is some mathematical calculations are associated, a task where some intelligent operations needs to be executed, or there could be some user flow where there are some human-like behavior are expected. Now, again, just to take an example of an intelligent restaurant system, think about an agent or AI agent which would work as a restaurant manager. So a restaurant manager is an use case where, and the agent needs to think like a human. For example, it needs to do some intelligent analysis about whether there is a shortage of inventory. If there are more orders are coming, it needs to automatically order some more inventory, and it needs to do the calculations. Based on that, it needs to put the order and all those things. So it basically, small agents will understand the requirement and it will make decisions on its own. And the best part is because it has the code agent, that means it can use different tool, or where there are no tools available, it can actually write their own code. I think that's what I have also mentioned somewhere in this particular readme file, which you will also get as part of the code base that I will share to you. And here I have said that small agents can run code to make smart decisions. The only powerful features that you would get with small agents that make it different than the standard AI agent that we usually have covered in this channel as part of the multimodal AI agent series with LiveKit. Okay, cool. Now what I will do is I'll run through all these 6 different type of agents that I have created for you to understand. The first example, which is the small agent basic. Now, as you can see, zoom it, yeah, zoom it now. Okay, so here you can see there are like exactly 3 lines of code using which we are able to actually run a small agent. Now, before you do that, please create an conda environments just by writing conda create -n, give it a name like small test Python 3.10. I have used version 3.10 because it's stable, but you can use 3.11, but I wouldn't recommend you to use 3.12 yet, because a lot of the Python libraries are still not compatible with 3.12, as I have seen with many examples before. But yeah, please use 3.10, and I have already activated that particular environment. So once you have created it, please activate the environment. These are all basic steps that I've covered multiple times with different other tutorials in the channel, so I'm not going to cover that here. Instead, I'm going to focus on the code so that you get understanding about small agents in a better way. Okay, cool. So what we are doing here, basically here, we are importing the code agent, the DuckDuckGo search tool, and HF API model. Now, code agent is something that comes from a small agent agent.py file, and code agent is one of the agent that they have created. And as I've said earlier, they created a tool agent, they created code agent, and they created multiple other agents that you are going to see when we go through the other example. DuckDuckGo search tool is something we would use to do some online search like Google search you do. So basically the agent will use DuckDuckGo browser and it will do the search based on the instructions that we will ask. And HF API model is basically going to use the HuggingFace model. So as I said, HuggingFace has more than 500,000 models that is already available there, and HF API model is actually going to use one of the model, and in this case it's using 0.2.5 CUDA 32 billion instruct model from Hugging Face inference endpoint. Now that really means is that you can actually run this entire agent for absolutely free, because you can get an Hugging Face access token for absolutely free. So go, if you haven't registered in Hugging Face website, please make sure you do the registration first. So just go to Hugging Face and do the registration, and then here you go to this access token, and then just create an access token. Just like you can see, I have created an access token. Once you do that, just clone this repository and go to this code. And here, as you can see, I haven't specified any kind of model because I just wanted it to use the default model that comes with this particular package. So what we are going to do is I'm just going to run the Python one.smol.py. And as I run it, you will see that it's going to actually run step by step. It will search the internet using the DuckDuckGo browser, and then it will give us the answer. Now it has given us the answer that it is 9.62. So it basically searched what is Pond Des Arts, which, and then it has also searched the speed of leopard, and then basically did the calculation. So basically it created this code and it executed the code. Everything it has done with just 3 lines of code. As you can see how powerful it is, right? And this actually runs for free. But one thing I forgot to mention is to be able to run this code, you just need to set the Hugging Face token into your terminal. So just do export HF token and then set the token that you will get it from here, and then run this particular code. So please make sure you do that. Don't forget that I have forgot to tell you about that at the first place. Sorry about that. But make sure you set the Hugging Face token and then you run this code, and this should be able to actually execute the code using the code agent. And the code agent also have the tools of DuckDuckGo search tool. So using that tool, it has searched all the information, and based on the information, it did write the code and it has found out the answer. Now you might say me, this is really good, but does that mean that we have to be always dependent on Hugging Face provided model? Can I not use any kind of closed source models if you have, let's say, a more complicated use case which may not be served using open source model? And to answer that, you can absolutely run it with any other model, even the closed source model. And if you go to their website, which is here, if you go to this particular support for LLM section, you will see that it supports model from their transformer version from their hub. That's what we have used. And it also supports model from OpenAI, Anthropic, and many other model using LiteLLM integration. So that means we need to use LiteLLM as like the API proxy to be able to actually connect with any model that you want to use. For example, this in the second code, which is this one's Smol Agent LiteLLM PY, I have done the exactly same thing. So basically what I have done, this only difference is I have removed the HF API model and instead I used LiteLLM model. And then in the model ID, I use GPT-4o Mini. That means in order to use GPT-4o Mini, I need to create an OpenAI API key. And that's what you also need to do. So please go ahead to the platform OpenAI API and basically just create an API key from here. And again, you will see that I've already done that with the Smol Agent test. So that's what I have set it here. So all you need to do is just set OpenAI API key equals to whatever token that you will generate from the platform OpenAI page. Just set it there and that's it. You do not need to do anything else. And this is just exactly going to do the same thing. So all I'm going to do is just run the second agent, which will use the GPT-4o mini model instead of the Hugging Face provided Qwen 2.5 coder model. And you will see here, right? You will see that it's using GPT-4o mini model. And again, it has used the DuckDuckGo search tool, and it has got all the information that it needs from the internet about the Pontedous length, and it has also get information about the leopard's average speed. And then it created a code, and then it executed the code, and then the final answer was 9.62, and that was the same answer that we have got with the Hugging Face model as well, right? So that means this is working. Now, the interesting use case, this is very basic use case. I'm sure this is only for prototype. You want to do some more complex stuff with this agent framework, right? Now, this third code is where they allow you to also pass in additional arguments. You can pass in image, you can pass an audio file or text file, your documents and everything, and you can still use the agents. Just to give you some idea, what I have done is I have downloaded this MP3 file from Hugging Face. So if you just click here, just run the file.
Oh, he has been away from New York. He has been all round the world. He doesn't know many people here, but he's very sociable and he wants to know everyone.
I hope you have heard it. If not, let me replay it again and hear it properly.
Oh, he has been away from New York. He has been all round the world. He doesn't know many people here, but he's very sociable and he wants to know everyone.
Okay, so we have listened to the MP3 file. Now what I will do is I will use the agent and I will ask, why does Mike not know many people in New York? And I'm going to refer this MP3 file. That means the model or the agent should be able to get the context of the information from the MP3 file, and then it should be able to answer why Mike does not know many people. I hope you know the answer because you have heard the MP3 file, right? Now, what we will do is for this case, we are using Hugging Face model, but you don't need to. You can use any model, really, that doesn't matter. And all we have to do is just set this. Once you run it for the first time, it will actually download the Whisper model from the Hugging Face hub, because it needs to transcribe this MP3 file. So it might just take a few moments when you run this particular file for the first time. And also make sure you install the accelerate and sound file library, because these two files are needed to run this particular file. Okay, so I'm going to run it and see what happens. So as you can see, it is now transcribing that particular mp3 file. Again, as I'm doing the recording and everything, it might just take a bit of moment. And as you can see, it is using multilingual whisper model to transcribe the text. And as you can see, it has been able to actually get the transcription from the mp3 file, and that it has used as a knowledge base. And then it is able to produce the final answer that the reason why Mike doesn't many people in New York is because he has been away from New York and has been traveling around the world, which is why he doesn't know many people there. And that is what exactly the MP3 file was saying, right? So that means you can actually use this additional argument as a parameter and specify any image file, any MP3 file, and just you need to use the transformer model based on whatever external file that you provide. Okay, you can even use other kind of text and RAG and all these bits, and they also have a really good documentation around how to use RAG. So if you go to the documentation here, they have all those information about how to use different RAG system with the particular small agents. That's good. Now let's go to the fourth one, which is where we are going to use some kind of image generation model to generate an image using this particular small agents. Again, to create an image, it's very simple. Again, go through the documentation here, tool in-depth guide, and just read through it. This is very self-explanatory, but what I want to say you is that the code that they show you here, this snippets, this does not work as it is showing here. So what you need to do is actually read through the entire stuff to understand how to actually define a tool, and then you just need to tweak this particular code a little bit based on the documentation that's been written here, and that's what I have actually done, so you don't need to spend that extra time there. So basically what I have done was I created an image generation tool class, because that's what they say here. If you can see that, what is a tool? How to build one? A tool mostly is a function LLM can use in an agentic system. But to use it, LLM will need to be given the name, tool description, input type, and description, and the output type. And that is why you need a class. So that's what the class actually is defined. So you need to define the class for whatever tool that you are using. And for the small agent framework, all you need to do is set up a forward method. And this forward method is where it's actually going to execute the code, like whatever tool code that it needs to execute. So that is why you need to define the forward method. And if you come to the code, that is exactly what I have done. So I have created the class tool, and I have done an init method, and in the init method I am loading the Black Forest Lab Fluxional dev model basically. So this is like a really powerful model when it comes to generate images. If you have not tried it yet, you must try it. This actually creates some brilliant pictures. And then I created this forward method, and in the forward method I'm just calling this cell.client.predict, and I'm giving the prompt seed, random seed, and the image width and height, the number of inference steps, and the API. The API is basically the default. I did not need to specify it, but I have just given it just for completion sake, basically. So that's what I have defined. And now what I'm doing is just creating an instance of this class here, the image generation tool class. And then I'm creating the HuggingFace API model. And again, we are using Qwen 2.5 coder model. You can use Llama.3, that's also fine, or you can use GPT-4 or Anthropic model. The better model you use, the better the output will be, of course. And then I'm initiating the code agent. Again, we need the code agent because we need to execute the tool. And then what we are saying that improve this prompt and generate an image of it. For me personally, I'm not really good at creating prompts when it comes to creating image, so that is why this prompt is really going to help me create a proper prompt for a rabbit wearing a spacesuit. And let's just execute this. So if you run the fourth, hit it again, you need the Hugging Face token for this, and you have already set it as part of this run, so you do not need to set it again. Should work. So it has now improved the prompt, the detailed illustration of rabbit wearing high-tech spacesuit standing on a rocky Martian space with fine texture and realistic lighting. So basically, what the agent have done is it uses the Queen 2.5 coder model and it created a much improved prompt, and it sent the prompt to this particular tool, and then it has created this particular image. So let's open the image. Just hope that, as you can see, this is the image that is created. It really looks so nice in my eye, at least. There are shadows there properly, and it really looked really nice. It's just that the rabbit ears have came out of his helmet, but yeah, that's fine. But it really looks cool. So that is how you run, you create tools, and as you can see, it is so easy to create tools. And in the output type we set image. So that's how you actually create custom tools, and you use the tool with these small agents. In the number 5 example, we are going to actually use tools, but we are going to use Langchain tools because that Langchain have a very much variety of tools, a vast pool of tools that you can use out of the box, so that you don't need to write the tools or create the tools. And this is where we are actually going to use the SERP API tool to do some kind of Google search instead of using the DuckDuckGo browser. But as I said, you can actually go to the Langchain community and you can actually search for the toolkits. There are numerous tools that you can use with the Smol Agents. And this is how you should use it. Basically, how you would use Langchain tools with Smol Agent is you basically import this load tool method from the Langchain community, and then you need to use the tool, code agent, and HP HuggingFace API model from Smol Agents library. Here I'm defining the SERP API key. How do you get the SERP API key is again very simple. Just go to SERP API key and go to the Google Search API console, sign in, and you will get the SERP API key as you can see it here. That's what I have set it here. And then you just write the search tool. Very simple, very similar like the previous one that I have done here. I created the class search tool, given the name, description, input, which is the query, and the output is a string, whereas in this one the output was the image. And that's it. Basically here what I'm saying is please load tool SERP API. So SERP API is the tool that it will load using the load tools function that we have imported from Langchain community. And then we have created the forward method, which will actually just run the tool with the query. Where the query will come from, the query will be coming from the agents. So in the agent we are saying who have won the latest world championship in 2024. So this is the query that will be passed to this particular search tool, this forward method. How it is going to do that is because we are using code agent again, and we are specifying the search tool that we have created there. I hope this is all making sense. And you see the agents are only what 36 lines of code, and I have actually added all these comments for you so that when you check out this code you will have a complete understanding of how it is working. Now what we have to do is to run this, you need to install the Langchain community node. Again, I have created the requirement.txt for you to install this Langchain community and Google search result. These three you need to install before you run the number 5 Python file. So I'm just going to do clear, and I'm going to run the 5 to Smol Agents. And it's using the Coin 2.5 coder model, as you can see, and it has searched in the internet, as you can see, and the final answer is Gokes to Maraju, which is the right answer, and that means this has worked. And as you can see from the execution log, it has searched the web, it has able to find the answer that Gukes have defeated the previous champion Ding Larin, which is right. And I have personally have watched the match. It was really interesting. But again, this is something is really awesome that we are able to do this kind of agent implementation within just 40 lines of code, and so easy basically, as you can see. And I think the name Smol Agents is rightfully given to this agentic framework. Now, before I proceed ahead, what I'm going to do is I'm just going to manage API key, and I'm going to remove this API key because this is already is going to be exposed. Now, coming back to the code, the sixth one, which is the final agent that I'm going to show you now before we jump into our business use case. So in this particular file, what we have done is very similar to the previous one. We created a tool, but this time you see we haven't used the class approach. We instead used the tool decorator. So you can actually define tool in two ways. You can use a tool decorator and just create a Python function and basically provide the name, the description, the argument, and what it needs to return instead of creating a class and give those details. So this is why we use the tool decorator. You can use this approach as well. And once you do that, you just define the Python function and you basically do whatever business logic you want to do. Here, this code I have basically copied from the documentation then itself that the HuggingFace team have provided as part of the Smol Agents implementation. What it is doing is very simple. It's just taking the URL and it is just going to mark down the content of the web page. Be careful, don't use this too much on your IP or on your machine, because this is something which is categorized by different website provider as bot scrolling the website, which is not legal, and as a result they could ban your IP. So do not use it too much. This approach is just for the demonstration purpose. So if you really want to do scraping, there are other legal or other efficient ways to do that. This is only for example. Again, I just want to mention. So when you are getting this code, when you are running some kind of testing, do not over test it. So just run once or twice to understand this and use some other approach, basically like the SERP API. And now in this case, what we are doing is we are using the DuckDuckGo search tool in this particular Agentic framework system. We are creating a multi-agent system. That means we will create 3 different agents. We created a web agent, which is a tool calling agent, not a code agent, remember, right? So that means this is only going to be able to do tool calling. So we will just provide the tool, which is DuckDuckGo search tool, and then we are going to give the visit web page tool as well. So this two tool we have given to the web agent, and then this web agent is going to be a managed agent, and that in a multi-agent framework you need a manager agent which will actually know what all different agent is available to this particular manager agent so that it can manage those agents. So that is why we created a manager agent, and in the manager agent we have specified what are the different managed agent that is available. So that is why we created the agent. I think they have created a really good diagram for this particular agent framework. This is the diagram that I was talking about, and as you can see, it's basically going to feedback whatever response the managed agent have given to the manager agent, and the manager agent is then going to collate all the information and then produce the final output. That's what is happening as they have shown it here. Same, if you go to here, this is what the actual diagram looks like, where you have the manager agent, and manager agent has the code interpreter tool. However, the managed agent has the web search agent. You can add more agents as part of managed agent. And the web search agent has web search tool and visit web page tool. And that's what, if you see the code, that is what is happening. The code agent, which is the manager agent, this has the managed web agent, and the managed web agent is the web agent, and the web agent has these two tools. The important thing is, if you see here, additional authorized imports. So this is really, really important. So for example, I have said you in previous different examples that code agent is able to execute code. That means it is able to create any Python code and run it in your local system, right? Which is not safe, and you should not ever do that. And that is what they also mentioned in somewhere in the documentation, that they realize that this is not a secure practice, and because of that what they have done is they have created a secure local Python interpreter module. So if you go to this code, I'm just going to quickly show you that here. Just copy that. So if you see that they have created an local Python interpreter as an executor, so it's not actually just executing on you, it's executing on your local, but it's not using the uh, Python environment that you are using to run the agent. Rather, it is using a local Python interpreter and that means it's going to create a kind of a logical environment within the program, and it's going to use that. And they have only given 5 or 6 Python module in that interpreter. So as a result, if you want to create some complex logic where you need to import multiple module, you need to specify those module here as add authorization import. So that means we need to run numpy pandas these modules to be able to basically run the code as we expect. And that is why we had to specify those modules. So that means in the runtime it will download or import these modules to be able to run it. So any other modules, so for example, if the LLM create code that doesn't have these 3 modules, maybe some other modules, then the code will not be able to run. It will generate an error, and then that error will be feedback to the LLM, and the LLM will then again recreate the code basically until it is able to run it. So that is why it is really important you use the additional authorized import to make it secure, because it is not really secure to run any AI generated Python code in your local setup. To secure yourself, additionally, they also supports E2B code executor. What is E2B code executor is basically E2B. Using E2B code interpreter, you can create a sandbox, and using the sandbox you run the code, not in your local system. So for that you needed a E2B API key. So you just need to go to E2B website and then just get a free API key. And once you have that, you can use the E2B executor code to run the code. So basically whatever code that the code agent will create, it will not run the code in your local laptop or in your local server. Rather, it will run it in a sandbox into an E2B environment, which is much more safer to execute basically, especially if you're running any kind of production application or some kind of sensitive use cases. So make sure you follow that. I haven't added those details here, but it's very simple. All you need to do is just use this code instead of this particular code agent, nothing else basically. And then what we do is we are saying manage agent dot run, and then we ask these questions. So we are basically asking it to create a report that if the LLM trainings continue to scale up at the current rhythm until 2030, what will be the electrical power consumption. So that means it's a bit of research oriented task. It is not a deterministic task. That means we can, or rather we should, use framework like Smol Agents. So I'm just going to run the 6th here, and should be able to run. Now it might fail, as I have told you, is because it's going to directly call a different endpoint. As you can see, this one, basically it's tried to directly call this particular website, and that website had rejected basically because it is using the request.get URL, which as I said, it's kind of a bot scraping, which is not allowed by different website provider. But that's fine. It is anyway going to get more information from all the other links. As you can see, it has got a lot of information from the internet, and it has reached the max iteration. What is meant by max iteration is, if you are working on some kind of research, you can actually set the max iteration here. That means the web agent will only do 5 tool calling or 5 website search. uh, you do not want to do thousands of iteration unless you are working on a very serious or on a very complex research work. But this is for demonstration, so I have just given 5 iteration, but you can do as much as possible. And as you can see, it has finally got all these details from the internet, and then it has generated the final answer that the estimated electric power required by 2030 is approximately 58.22 gigawatt, with a total annual consumption of about 510. So basically, this is what the report that it has generated by going through different website and got all the informations and then created the report. So I really hope that you have had a lot of insights about how to use Smol Agents with the 6 example. Now what we will do, we'll go to the next part of the video where we will actually show you how to use it in a real life business scenario. So see you on to the next part. Welcome to the second part of this crash course on small agents, and in this part we are actually going to create an real life business use case that you can actually implement using small agents. In the first part you have already seen that we have created 6 different example code to give you some hints about how to create a basic small agents, to create different tools, how to use different multi-agent system and everything. So I really hope you have had all the knowledge from this particular section. Now in this section what we are going to do is we are going to use all those knowledge that we have gathered from the first part of the video, and then we are just going to create a very simple intelligent restaurant system with small agent. And I think I in the first part I have been taking an example of a smart intelligent restaurant system is where you have an AI agent that can perform the role of an hotel or restaurant manager. That means the agent should be able to understand what as an user you're asking or as an owner you're asking. It can make decisions on its own. It can use different tools to help you make decisions, and it can learn from its own query and tools as well. Now, why use small agents? Again, just to give it some context, is in traditional programming, if we give specific instructions, that means if we say, hey, if there's an order received, then it will do check inventory. If inventory is okay, then it will just process the order or it will reject order. This is what we can do with a traditional programming. However, in a real life, this is not something that is realistic, right? So in real life, if there is an order received and it checks the inventory, and a human manager or someone like in your restaurant, or someone who is responsible to run the restaurant would actually check the inventory, and if he sees that the inventory is low, it will immediately put an order for the inventory. It will do it beforehand so that the restaurant doesn't miss any order, right? So in real life scenario, this kind of traditional programming doesn't work, and that is where we need humans to make decisions. But with small agents, what we can do is we can handle complex situation, like if customer wants to modify their order but the kitchen is busy and some ingredients are running low, then the small agents can make decisions based on the available functions, based on the available tools, based on the available resources, right? So that means it can check the kitchen capacity, it can look at the inventory, it can do some automatic ordering of inventory, it can calculate delivery times, make different smart decisions as an human would do generally. And this is all we can do using small agents, because this is very lightweight agent and we can implement that using this framework. I have picked up a bit of snippets from the actual code base and put it here for your reading purpose and for understanding purpose. So please go through this particular readme file, and that will give you some really good idea about how to use these small agents for a real life use cases. Now what I'm going to do is quickly just run through the code that I've created, and it is very simple use case that I've created, so it's not going to take a lot of time. So the first thing what I've done is I created 3 tools. One is the analytics tools. So again, this is custom tool. That means I created a class. It will given a name, and what it is going to do is it analyze sales data and generate insight. That means you can use small agents to do data analysis task as well, and it can do analysis of daily, weekly, trend, and forecast. So it can do forecasting and everything. You can specify the number of days to analyze as well, and based on that it can generate report. Of course I use some sample data here, but in a real life use case you will have database where you will have all these details, like the date, the number of sales, the number of orders, average ticket, and everything. So these are all going to be in database probably, but in this case I just created a random integer between these two numbers for this particular example. Very similar like that, we created a forward method. That means if the analysis type is daily, then it will call the daily analysis method. If the analysis type is weekly, like the user have asked, hey, can I get the weekly inventory report for the last week or something like that. So if it is a weekly one, then it will run the weekly analysis. And if it is trend analysis, it will do trend analysis. And if it is a forecast, it will do the forecast analysis. Every case here for this example, we use dummy data, but as I said, all you need to do is just change this particular method with actual database link, right? Nothing fancy there really. Of course, it's using NumPy modules to run the analysis. So that is why you will see we have imported NumPy. But as I have told you in the first part is when you create the agent, you need to specify the modules. Like here, I have specified the authorized import as NumPy because if I don't specify it, this particular code agent won't be able to execute the code, right? So this is security that they have implemented with code agent. So please make sure you do that. Now, this is the analytics tool. Similarly, we have code execution tools. That means if the code agent needs to execute some code, it can actually again use a NumPy, pandas, and everything, and it can give the code to this particular tool, and this will actually execute the code here in this particular section. Again, every section is written with a specific instruction. So when you check out the code, just go through the code base and go through the instructions so you will better understand it. Similarly, we created another tool called inventory tool. This tool will basically help the agent to know or check the current inventory, update current inventory, alert if there is a low stock, or it will optimize the inventory as well. Okay. Now, as you can see, these are different functions and very similar to the previous one. We have a forward method, and in the forward method, if the action is check, it will call the check inventory method. If it is update, it will call the update inventory method, and similar for get alerts and updates. So simple three tools that we have created, and then in the UI, we created a dashboard.python file. We'll come to this one later. Let's first go to our main file. So in the main file, what we have done is we created a sprint management system, and we have initialized all the tools that we have created here. And then we created the agent. Now by this code, we are calling the create method. In the create main agent method, we are creating a code agent, and we are giving all the tools that we have created so far. And then we are using the HuggingFace API model. We can, as I've said, you can use any other model. If your use case is more complex, you can use like GPT-4o model or Cloud model. Just use the LiteLLM method that I have shown you in the first part of the video. I think here is the LiteLLM model, so use that one. And then here we have specified the additional import as I have shown you already. And here I've given the max iteration 5. That means I do not want this agent to go forever. Again, this is for demonstration purpose, but you can set it to 10, 15, whatever is necessary. And then you have this particular method called process command. Now this process command method is not something that the agent uses, rather this is basically being called from the UI. So what we have done, we created a simple UI to showcase you for your better understanding how this is working. And then in the main method, we created the dashboard, which is the UI. And then from the UI, we create interface. That means we are using Gradio for UI for this particular project. And then it's basically launching that particular Gradio project, and which will call the process command method. So if you go to the dashboard.py, what we have done is we created 3 different tabs, one for the command center, one for quick action, and one for analytics dashboard. And for everything that you click on the particular UI, it's basically going to create execute command method. So if you go to the execute command method, you can see that it's basically calling the process command method from this particular main.py. So this is the process command method. So the process command method in turn is calling the agent.run with the command that is coming from the UI, right? So I hope you're able to get it, right? Again, just to repeat what is happening in the dashboard.py, you have the user interface. In the user interface, you provide the command. Once you provide the command and click enter or hit enter or click any button, that's calling the execute command method. And from the execute command method, you are calling the process command method, which is in the main file. And then process command method is actually running the agent with the command that is coming from the UI. I hope you are able to get it now. Very similar to before, just set the HF access token. I have already set it. So just export HF API token and set the API token that you have copied from the Hugging Face. But if you are using LiteLLM or like GPT models, maybe just get a platform OpenAI API key and set as OpenAI API key. But in that case, please make sure you update this model with the LiteLLM model class that I have shown you here, like this one. So make sure you do that if you want to use any closed source model for your use case. Now what I'm going to do is just run python main.py. Again, you have the requirement.txt and everything. Just do a quick installation like pip install -r requirement.txt. That will install all the required libraries and everything. I'm not covering that. These are all the basic stuff, right, with Python. Now, as you can see, the URL is live. So we can just go to this particular URL. And there you go. Our restaurant management system powered by AI is ready with Smol Agent framework. Now, what we can do is we can just give some commands, or you can use the quick actions to quick check. If we do kitchen status check, you can see that it's using the Qwen 2.5 coder model, and it is running the kitchen status command. And you can see the kitchen status is operational, all device functioning, no issue reported, staff allocation, manager Alice, chef Bob, waiter Charlie, and cleaner David, that we have set. But you can actually get all of this from database as I've shown, as I've told you earlier, right? Similarly, if you go to the command center, and let me just give it some command now, just to show you how you can test this particular code. So let me ask how much tomatoes we have in the kitchen, right? And execute command. Now it has executed this particular through the agentic framework, and the agentic framework have used the tools to find out the tomato quantity, and then it has responded that we have 50 kg of tomatoes remaining in store. Similarly, we can do some tricky one. For example, we can just say here that we are expecting 25% more order tomorrow. Is our inventory sufficient? So we can ask that to the AI agent, and it should be able to get through the inventory and get us the result. So it has now got the data, what inventory we have got, and now it will just check 25% increase in order, how that is going to impact the particular inventory. So as you can see, it has created some code for doing that check, and it is executing the check, and it says it's no. So that means it says that the inventory is not sufficient, because it is expecting today's order was around 200. So tomorrow they are expecting 250 orders. So that's what, so it's basically checking here that if it is sufficient, expected order is less than today's order. I'm just not going through the code, but what I wanted to show you is that it is able to do the actual coding that is required to do the analysis. And as part of the coding, it is able to find out that tomorrow's inventory is not sufficient, and it is able to tell you that. I think the analytics dashboard is not working. We have to fix that, because I don't see any call is coming there. But anyway, I'm gonna work on this particular dashboard.py and maybe update the analytics dashboard. Meanwhile, go through this code and download the code from the link below for absolutely free, and then let me know what you want to see more as part of the Smol Agents. And if you have any doubts or any confusion, the only thing that I want to tell you is that Smol Agent is still new, it's still in beta, and I'm sure they are going to update this agent for much more in the upcoming days. So maybe just wait a few weeks or months and see how much they are progressing. Keep a track on their particular documentation space, and I think this particular agentic framework is really going to be massive in the upcoming, in this particular year, in 2025. And we are going to be able to see this kind of more agentic framework coming into the internet, in the open space or in the open source community, which is only going to get better uh, and solve a lot of this complicated problem, hopefully using AI agent frameworks. With that said, I'm going to end the video. I really hope you have had some value and have learned something from this particular crash course. If yes, please let me know in the comments, or give this video a like, because that is going to actually help me understand your learning needs, and as I say in every videos. And also, if you can, take the SaaS course that I have already launched, because that is where I'm going to actually use all of this agentic framework, hopefully. And I'm planning to create my own multimodal AI agent SaaS, and you are going to actually see that process from start to end in that particular course. So if you can take the course or maybe take the membership of the channel, because that will directly and immensely help me create this kind of contents and continuously provide value into this channel. And with that said, I'm going to end the video. Please take care. Again, subscribe to the channel and peace out. See you on to the next one.